For my chemistry project, I will be explaining the ideal gas law. The ideal gas law is an equation, PV equals nRT, or PIV-NERT. Here is some background about the ideal gas law. The ideal gas law is an equation. An ideal gas is a theoretical gas that behaves in a predictable manner by following the ideal gas law. At STP, standard temperature and pressure, most gases will behave like an ideal gas. This law, the ideal gas law, is a combination of Charles' law, volume divided by temperature equals constant, and Boyle's law, pressure times volume equals a constant. Emile Clapeyron created the ideal gas law in 1834. Let's take a closer look at each of the specific parts of the ideal gas law. Let's take a closer look at P. P is equal to pressure. Pressure is a ratio describing the force of a gas compared to the area that the force is applied. Pressure is measured in atmospheres, abbreviated ATM. Pressure is inversely related to volume, and pressure is directly related to temperature and the number of moles. Now let's take a closer look at V. V is equal to volume. The volume of a gas is the quantity of the three-dimensional space. Gases take the volume of their container. The volume of a gas is measured in liters, L, or milliliters, ml. N. N is the amount of gas. The amount of gas can be referred to as the chemical amount. The chemical amount is proportional to the number of elementaries present. The amount of gas is measured in moles, abbreviated MOL, mole. 1 mole contains 6.022 times 10 to the negative 23rd particles. This could be atoms or molecules. This number is known as Avogadro's number. R. R is the universal gas constant. The universal gas constant is a physical equation. It is defined by the amount of volume, L, and pressure, ATM, per temperature, K, and amount, MOL. The universal gas constant relates all four of the variables in the equation. The constant value is 0.0821 liter atmospheres per Kelvin times mole. Having a constant in the equation allows it to work for any ideal gas. Finally, T. T is equal to the temperature. The temperature of gas is measured in Kelvin, abbreviated K. The Kelvin scale starts at absolute 0, 0K, or negative 273 degrees Celsius. To get the Kelvin temperature, measure the temperature in Celsius and then add 273 degrees. Now that we know about the equation, let's put it to use. By knowing the ideal gas law and having values for all but one variable, you can solve for the unknown. For example, if the pressure is 1.4 atmospheres, the volume is 3 liters, and the amount of gas is 2 moles, and we already know the universal gas constant, we can solve for the temperature. What is the temperature in Kelvin? Well, at the top line we see the equation, and after solving for K, we get 1.4 atmospheres times 3 liters divided by 2 moles times the universal gas constant equals K. K is equal to 25.58. This means the temperature in Kelvin is only 25.58 degrees. That's well below freezing. Here are some of my sources that I used. I used a website from Georgia State University and one website from UC Davis. I've also got a link to some practice problems. They're very helpful if you don't quite understand the ideal gas law. Also, if you want to look back at my Prezi, I have included the link to that as well. Thanks for watching.